Then we have seen the periodic table, the classification of elements, and in that, in the beginning, we know that the attempts were made by three scientists, Dobrynin, Newland, and Mendeleev. But their classification was based on atomic mass. Why atomic mass? Because in 18th century, British scientist John Dalton suggested that the characteristic of atoms of an element is atomic mass, and that's why they suppose the atomic mass to be the property of the elements. But later on, in 20th century, when the atom was divisible, found to be divisible, in an atom they found three particles, electrons, protons, and neutrons, in which the number of protons is fixed, and we know that number of protons is equal to number of electrons, and number of protons equal to number of electrons, and electrons, number of electrons give the electronic configuration. And as we get the electronic configuration, then we will separate the electrons in various orbits. In the first orbit 2, second orbit 8. And in this way, we'll find that in the last or outermost orbit, some electrons remain. And accordingly, the property of the element is the number of electrons in the outermost orbit. And that is called valency. See once again, so based on atomic number, so modern periodic table is based on atomic number. Atomic number is the number of protons, and we know the number of protons is the number of electrons. Number of electrons gives us electronic configuration, and when we write the electronic configuration, then we find the electrons in the outermost orbit. So electrons in the outermost orbit is the valency of that electron we call, and valency is the property. Valency gives a property. At the same time, we'll find the number of electrons in the outermost orbit is a group number, and therefore there is a relation between the group number and the valency, and the group number and valency, and that's why group number gives the properties of the elements, and therefore you'll find that all the elements in the first group will have similar properties, all the elements in the second group will have similar properties. That's why elements come in a particular group will have same properties. Acha, now next we have divided the long form periodic table into 4 blocks. Here 4 blocks S, P, D, F. These are 4 blocks and very important blocks. Of these 4 blocks, first block S consists of only two elements, not more than 2. Then comes P will have 6 elements. Then comes D will have 10 elements, and then F 14 elements. So keep in mind that S, P, D, F are the blocks. So F will have 2 elements, and if we take the third period, so in third period the elements are sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. So here in the third period, the first 2 elements, sodium and magnesium, come in S block. Of this, sodium is the first. So all these elements come below the sodium are called alkali metals, and these I explained last time. Why alkali metals? Because they form alkalis when they combine with non-metals. So alkali means they are bases, but bases that dissolve in water called alkalis. So we know sodium hydroxide, potassium hydroxide. So all these are the important alkalis, and these alkalis dissolve in water, and that's why they are called alkaline metals. Then second, called alkaline earth metals, because these metals are found in the earth, and that's why they are called alkaline earth metals. Then next group comes P group. All these P group they come: aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Acha. Now here you will find one more characteristic. You will find that as you go from left to right, we will find the size of an atom decreases, and this I explained last time. Why size decreases? We will find that as the number of proton increases, as you go from left to right, the number of proton increases. Let us take the example of sodium. Sodium has 11 protons and therefore 11 electrons. So sodium lies extreme left, whereas chlorine has 17 protons and 17 electrons. We know protons have positive charge, electrons negative charge. Of course, there is attraction. So protons lie in the nucleus and electrons revolve around the nucleus. But as the number increases, here 11 and here 17, so we know the number has increased. As the number increases, the attractive force increases. And as the attractive force increases, then these electrons, the outermost orbit electron and all the electrons are attracted towards the nucleus. You will find, just compare that sodium nucleus or sodium atom with chlorine atom. You will find the orbit number same orbits are there. Here 3 orbits, here also 3 orbits. But all these 3 orbits have come closer here. Why? Because of the attractive force. So as the proton number and electron number increases, you will find the attractive force increases, and that's why this circle will become smaller. Here the circle is larger. So of course the volume of the atom will be more, and here the volume will be small, and therefore the size decreases. So keep in mind that as we go from left to right, the size decreases. As the size decreases, you will find the attraction increases, the size decreases. So as the attraction increases, the electrons are attracted towards the nucleus, and therefore they do not lose easily. And as they do not lose easily, you will find that the metallic property decreases, because metallic property depends on losing electrons. Losing electrons. Here sodium can lose electron easily because it has only one electron in the outermost orbit and it is far up from the nucleus, so it can lose easily. So losing electron easily is the strongest metal, and that's why you find the sodium is the strongest metal. Magnesium is metal but not as strong as sodium, because in magnesium you find that 2 electrons are there. And if these 2 electrons are there, so attractive force increases, and that's why they come closer, and that's why the losing capacity decreases. As the losing capacity decreases, then it will metal, but its metallic character decreases slowly. So you'll find the metallic character decreases, and as metallic character decreases, non-metallic character increases. So sodium is the strongest metal, we know, and that's why sodium is kept in kerosene, not even water. It is highly reactive. It is never found in atmosphere in free state. It is always in combined state. We know common salt is a sodium chloride. So it is found in compound state. Why? Because strong metal it is and highly reactive. Whereas magnesium you will find also compound state, but we can separate magnesium, and magnesium can remain in atmosphere. Then aluminium. Aluminium shows both the properties, and that's why it is called amphoteric. It shows both the properties. Then silicon. Silicon is neither metal nor non-metal, because it is on the border of metals and non-metal, and that's why silicon is called metalloid. Now next you will find phosphorus, sulfur, chlorine. So their metallic property decreases and non-metallic property increases, and we know that chlorine is the strongest non-metal, and it is in the gaseous state. Whereas argon, the last one, here the last orbit is completed, and since the last orbit is completed, there is no that means give and take of relationship, that means give and take of electrons, and that's why they do not form compounds, therefore they are called inert gases. In the monoperiodic table, once again, let's see, as you come down the group, you will find the first group, very first, they are the 1 orbit. Second period, 2 orbits. Third period, 3 orbits. Fourth period, 4th orbit. So you will find that as you come down the group, you will find that number of period increases, and the period depends on the orbit number. So we know that first period 1 orbit, second period 2 orbits, third period 3 orbits, and then as the number of orbit increases, you will find the size increases. So we know that as we go from left to right, the size decreases, left to right. size decreases. Atomic size decreases, and this is due to what? This is due to the increase in the number of protons and electrons, and therefore attraction increases. But as you come down the group, you will find the size increases. So from down, top to down, from top to down, size increases. Why size increases? Because number of orbit increases. We know that, let us take example of sodium and potassium. The sodium comes in third group, and potassium third period, and potassium comes in fourth period. So third period, 3 orbits are there, and fourth period, the 4 orbits are there. So you find the outermost orbit in third, outermost electron in third orbit, and your outermost electron in the fourth orbit. So your 4 orbits are there, and 3 orbits are there. As the number of orbit increases, you will find the size increases, and therefore from top to down, the size increases. As the size increases, you will find the electron goes away. Here the electron is closer, and here the electron is far off, see, far off. And therefore, in potassium, the losing of electron, the tendency of losing electron is easily more than in sodium. The sodium electron cannot lose as easily as in potassium. So in potassium it can lose easily, and that's why we know that potassium is stronger metal than sodium, because the metallic property depends on losing of electrons, and non-metallic property gaining electrons. So here potassium can lose electron easily than sodium, and therefore potassium is stronger than sodium. So as you come down the group, you will find that sodium, potassium, then rubium and cesium, francium, all these metals become stronger and stronger, stronger metals are there. On the other hand, you will find the last 17 group, as we know, the fluorine, iodine, bromine and iodine.